طيب وما بعد التعب اللي هو حسوا بالفرحه والفرحه اللي بتخرج. Great. So last time we continued talking about the random process and we started talking about correlation functions. And just to summarize very quickly, the random process زي ما قلنا, and I'm repeating that this is a very important point. I want it to go into your head my time. The random process is unlike a random variable. A random variable, when you run an experiment, you get a number, a reading. Okay, and hence basically when you run the experiment again, you get another number. Now, how is this probability of equal one distributed among the different numbers is what we call the PDF, and or the probability density function. And knowing the PDF of one random variable gives you everything about it. Everything you can know. The average, the variance. Now, if you have two random variables, now running the experiment, once you get two numbers, again you get another two numbers. Now, how are these numbers related? Gives you the joint between these two random variables. Now, in the random process, every time you run the experiment, you get a sample function or a linearization or a time function. Okay? Now, this time function, if you run the experiment again, you get another time function. The kind of experiment means running the experiment means selecting the student, then you get his GPA value of the different systems. Or selecting allocation and running or receiving the code will get you the signal received by the mobile phone. Or selecting the city and looking at the temperature variation over the year. So basically, every time you select the output of the experiment, you get a time function. The collection of these time functions are called the incident, or the whole thing is called the random process. If you have a discrete random process, we call it random sequence. If you have continuous time, you have a random process. In general, it's random process. Now, in order to understand how the random process works, or the behavior of the random process, so we are able to filter it, signal process it, and so on. We need to understand the relationship between the random process at certain time and another time. The random process at certain time, right? We call it x of t1. The random process at another time, it's another random value. At a third time, it's a third random value. We have infinitely many random values. Knowing the relationship between one random value and another will give you some information about how fast or slow the random process changes, and tells you how much you need, how can you filter and signal process this random process. Now, in order to understand the random process, first of all, you can know the distribution or the PDF of one of these. We call this as first order distribution, right? If I know the PDF of one random variable at a time, x of t1, I know its distribution, x of t2, I know its distribution alone, without knowing the relationship between that random value and another time, then this is the first order distribution. Now, if I know the joint distribution between two random values at t1 and t2, or t equals some, or t2 and t3, and so on, these are called second order distribution. Now, if I know the PDF, the joint PDF of n of these random values, this is called nth order PDF. Okay? At time one, you understand. Time one, run the experiment about selecting a city, cover Riyadh, others, Washington, New York, and so on. Selecting a city gives you a temperature at January. At January, probably will give you another temperature. Riyadh will give you a third temperature. Now, the collection of these temperatures is the random variable at T1. The collection of these temperatures in February is another random variable at T2. ممكن يكون الافرج هنا مختلف عن الافرج هنا، الديستريبيوشن هنا مختلف عن الديستريبيوشن هنا. اوكي؟ الديستريبيوشن ممكن at T1 at January and July might be totally different. Now, the relationship between two random variables is the second order, gives you the second order distribution. مثلا between temperature in January and February. لو تلاحظوا حيكونوا لهم آخر فيهم بعض لأنه كل شيء. بينما January and March, sorry, January and July, they might be totally different or opposite equation. واضح؟ So what we tried to do last time is to at least set up the problem like this. In order to understand the random process, we need to know the first order distribution, the second order distribution, third order, and so on, which is impossible. يعني for any practical purposes, this is impossible to do. But at least this is what you need to do. So تكلمنا عن definition with notation. We said that okay, first order distribution, we added a T1 to represent X here is random process, and we added X1 is the dummy variable such that it's equal to the probability that X of T1 at T1 is this random number. This is the notation. When we have two, then basically we added T1 and T2 to represent the times that X of T1 is this than X1 and X of T2 is this. And so. And then we talked about the mean function correlation. We said that, okay, now if we look at what is the average of this random variable at T1, it gives you a number. The average at T2 is give you another number. At T3 gives you a third number. So for versus time, it gives you function of time. A function of time. So the mean here is not like in the random variable, it's a number. The mean here is a function of time. Well, and this is what we refer to as mx of t, which is expected value of x of t. And the way we calculate it in the discrete and the continuous as mentioned. So you need to have the first order distribution to be able to find it. Okay. Similarly, the autocorrelation function, we called it auto because we are looking at the random process itself. So the relationship between the random process at certain time and itself at another time. So here we are looking at Rxx of T1 and T2 means that it's the relationship, the correlation between X of T1 and X of T2 at time 1 and time 2. If they are highly correlated, means that the random process is a little bit slow, or if they are uncorrelated, means that the random process is very fast or changing. And this is the way we calculate it. والآن بعد كده تكلمنا عن covariance, there is another definition, and then the cross correlation, which is the relationship between two random processes, X of T at T1 and T2. And we continue with this. And then we discussed the independence and correlation. We said that two random processes are independent if the joint PDF basically decouples into the marginal joint PDF of X of T and Y of T. They are uncorrelated if the covariance is 0, or they are orthogonal if the correlation is 0. And if they are independent, then they are uncorrelated. Otherwise, vice versa is not usually not necessarily. Now, and then we solve the question, or at least give you an insight on how to calculate these functions, covariance, correlations. Now, let's talk about an important, again, we are still in the process of trying to understand how to model the random process. Technically. So, we talked about the correlation with the functions in this functions. Let's talk about what we call stationary random process. Now, if you have a random process whose PDF or properties change over time, we call this random process as non-stationary. Non-stationary معناها خواصها statistical properties مهما تتغير بعدين. الافريج تتغير، البي دي اف تتغير and so on. بينما if you have a random process whose statistical properties لا تتغير, doesn't change, we call it stationary. Stationary معناها ثابت. So stationary random process if all properties, statistical properties. Statistical means what? PDF, CDF, means, moments, and so on. Statistical properties do not change with time. In our first order stationary random process, when we call a random process first order, من الاسم, when the first order PDF does not change with time. So if I look at random process now at T1, and I look at it at T1 plus delta, any delta, they are the same. Okay? In PDF, they are the same. And I'm going back to the random process that describes the weather. Is it a stationary or non-stationary? Why? لأنه بشكل واضح الافريج حق التمبرتشر يتغير من جانوري إلى مارس إلى جولاي صح ولا لا؟ So it's very clear it's non-stationary random process. بينما نتكلم عن الجي بي اي حق الطلاب في السمستر نفس الجاء تبعتها معدل القبول معدل الانشاء. So we are not changing anything in terms of quality. So do you think that per semester average of the student will change? The average GPA ما حيتغير. إذا تغير يعني 1% 2% شيء يعتبر يعني negligible. The PDF, do you think it will change? It will have the same average kind of Gaussian distribution because it's meant to be like this. It's built like this. The system is built like this. So this basically tells you a stationary and hypothetical signal station. If you receive a signal in this location or other places, if you receive it today and keeping the same distance and receive it tomorrow, will it have the same distribution? Most of the time, yes, because the average of the signal, the power of the signal will depend on the distance. If I'm fixing the distance, it's the same. So this basically tells you physical means of different stationary versus non-stationary. So this is the first order. On here the proof of if you have a first order stationary, then the mean function is constant. ليش؟ لأن الPDF نفسه. So if I look at the average at this time or this time, they have the same PDF. So what do you think the average will be? If I have the same PDF at T1, the same PDF at T2, the same PDF at T3, and so on. So what do you think about the average? It will be the same. The average here is the same as the average. So the average will be constant. So the mean function is a constant function. Okay? And the way you look at it from the derivation, if you look at if you define x1 as x of t1 and x2 as x of t2, and then basically x of t1 is basically the integral of x multiplied by the PDF at t1, right? And x of t2 is the PDF multiplied by x, however, the PDF here at x t2 and here at t1, right? Now just make simple change of variable. T2 equals t1 plus delta. Then x of x2 will be x of t2, which will be PDF, however, at t1 plus delta. Right? And basically, now if this equals this, if the PDF at T1 equals PDF at T2, then we have here what? X multiplied by the PDF at T1, and here X multiplied by the PDF at T2. This one is the same as this one. They are the same. Which means that X at T1 plus delta equals X at T1. Which is what we say. So basically, the mean is constant. So physically, we know and we understand it. It's constant. However, this is mathematically, this is the way it is. Now, in the first order stationary, you can define the second order stationary. Second order, when the joint PDF, the second order stationary means that the joint PDF of x1 at t1 and at t2, it's equal to when you measure a different location in time. So if you have the PDF at t1 and t2, the joint PDF at the random values t1 and t2, if you do the measurement again after delta by fixing T1 and T2, so just checking both of them by delta, if the PDFs are the same, then we call it as second order station. Means that the joint PDF of second order doesn't change with time. Now just allowing delta equal minus T1, then f of PDF at T1 and T2 will look like just by delta equal minus T1, it will be like T1 will be 0 here, and T2 will be T1 minus delta minus T1, which is equal to delta. So basically, this means that this is equal to fx, x1, x2, 0, and delta. That's notation. Now, what do you think? If we have second order stationary, is it first order stationary? If I have the joint PDF fixed, is it first order? If you look at it here, the first order stationary, first order PDF is the marginal of the second order PDF. So marginal على x2. This is the first order, this is the second order. If I have the joint PDF at T1 and T2, I can find the first order PDF at T1 by taking the marginal with X2. Now, if I have a second order PDF, second order stationary, means that this is equal to when I have T1 plus delta, T1, T2 plus delta. Okay? Now, taking the marginal again will give me Fx1 at T1 plus delta, which means that if I have second order, I have second order stationary, means that I have, second order stationary means I have first order stationary. If I have third order stationary, I have second order stationary. And one very important result from in first order stationary was that the mean function is constant. Now, another similar very important result from the second order stationary is that when you have second order stationary, the autocorrelation function at T1 and T1 plus tau ما تتغير بالتau. Basically, it will be only function of time. ما تتغير بال T1 and T2. So, for example, if you are looking at the random process, هذه واحدة وهذه another one, and so on. Okay. And we are looking at certain time T1. So this is T1. This is T2. T1 plus delta. Okay. So I'm looking at the joint PDF, the correlation between the random variable at T1 and T1 plus delta. If I'm looking at the correlation between this random value and this random value. This is the result. Function or number? Number. It's a correlation, right? Correlation between x of T1, x of T1 plus delta. Now, if I repeat this after tau, if I repeat this, sorry, tau, نفس النوتيشن. T1 plus tau. Now, if I repeat this, however, after very long time, for example, T3 plus tau. Okay, and نكمل بس. Okay, at T3 plus tau. Now, the relationship between the random process between these two random variables, كم الفرق في التايم هنا؟ tau seconds. كم الفرق في التايم هنا؟ هذا ممكن يكون الآن، هذا ممكن يكون بعد ساعة. If this correlation is the same as this correlation, باختصار ما تفرق متى سويت المجال. As long as you keep the time difference between the samples, between the random variables the same, then this is what we call as the autocorrelation function does not depend on T1, does not depend on the absolute value of time. It depends on the time difference. Difference between what? Between time samples. Time. Voilà. So if you do the measurements of the correlation today between 1 second and 1 second and a half, and after 1 hour, 1 hour and 1 second, 1 hour and 1 second and a half, as long as the difference between the time instances here and here is the same, the correlation is the same. Okay? From where did we get this? Because we have second order station. Because the joint PDF is the same. معناها الجوين هذا الautocorrelation تعتمد على ايش؟ على الجوين PDF. So if the joint PDF here is the same as the joint PDF here, then the correlation will be the same. واضح كده؟ Any questions about? Signal. Here, احنا قلنا random process has to have a random component, right? So if you have a sine signal, either the amplitude is random or the phase is random. ما ينفع sine to sine 2 باي is a deterministic signal. So either you have a delta, a phase, random phase, or an amplitude that is random. So suppose that the amplitude is random, then the sign will be changing like this. Right? This is number one, realization number one. Realization number two will have smaller. So نفس frequency, like it should be the same frequency but smaller amplitude. Okay. If you have another one, it would be much smaller amplitude. Okay. So different amplitude, different realization will give you different amplitudes. If you look at the relationship at this time between these two times and between these two times, if the PDF fixing the time difference as tau هنا وهنا, the correlation should be the same. As long as the tau is the same. Now, if you change tau, يعني خلينا نقول you change tau, مثلا ناخذ من هنا إلى هنا, from here to here, another tau. Then you measure with another tau, the new tau, the new correlation here in الأخضر يعطيك نفس correlation هنا. Changing tau will change the correlation, not changing when did you do the measurement. ما تفرق أنت بدأت هنا ولا بدأت هنا. واضح شلون الفكرة؟ Now, so this is what we call the second order stationary concept. Now, زي ما انتم شايفين, you have levels of stationary. You have the first order, and you can only be joined with single media. You get one by one. Okay, sure. عشان يكون عندنا نفس الكورليشن. ونفترض السيجنال نفسها نفسها يعني كل فترة. نعم. عشان يكون عندي نفس العلاقة اللي بين. لا مش ما علاقة, مو لازم تقول نفسها. تعيد نفسها نسميها سيكليكال تاندم، مو شرط انك تعيد نفسها. كيف عرفت ان نفس الكورليشن قاعد انا ما اعرف. انا ديفايننج ايش معنى ستيشنري. انا ما اعرف. انا not saying انه هذه ولا هذه لها كذا. I'm saying انه اذا كانت ستيشنري second order هذا اللي حيصير. ايش يعني ستيشنري second order؟ means that الجوينت بي دي اف between these two random values, الجوينت بي دي اف هو نفسه الجوينت بي دي اف هنا، هو نفسه هنا. as long as I'm keeping count the same. إذا الجوينت بي دي اف هي نفسها، طيب اللي معناها أي فانكشن يطلع من الجوينت بي دي اف is the same. لأنه هذا الأوتو كورليشن is a function of the joint PDF. يعني كيف أطلع هذه؟ أسوي دبل انتجرال of the joint PDF صح؟ So if the joint PDF is the same, doesn't change with time, means that as long as you are fixing التاو. هي الفكرة إيش معناها؟ معناها إنه statistical properties of these random variables ما يتغير مع الوقت. اليوم ولا أمس ولا بعد ساعة ولا بعد شهر it's stationary ما تتغير. ثابتة. statistical properties ثابتة. The first order, I'm looking at only one random variable. الPDF ما تتغير. هذه نفس هذه نفس هذه نفس الPDF هنا ما تتغير. وأعطينا مثال الويذر واضح إنه الPDF هنا مختلف عن الPDF هنا كل شيء. صح؟ الجوينت sorry second order لا I'm not looking at only one PDF one random variable. لا I'm just شوف العلاقة بين two random variables. February أو January February. الترم نمبر 1 والترم نمبر 2 الجي بي حق الطلاب. العلاقه اللي هنا بينهم اذا هي نفسها العلاقه اللي بين الترم الثالث والرابع الترم الخامس والسادس as long as I'm keeping tau the same then we call this as a second order station. هذا بيكون مع السامشن ولا بيكون مع بعض؟ لسه ما جينا للبروبلمز. you are defining لسه هاي كونسبت. بس كونسبت يكون عندي معطى ويكون هذه تحت وضع. لا هي غالبا هذه كونسبت حنبني عليها كونسبت مهمه جدا هي اللي حتصير معطى. هذه الى الان كونسبت خلينا نقول عام هنبدا الان نحدد فيها. اذا اعرف اذا انا خلينا نقول انا قلت لك انه السكندري ستيشن واعطيتك الكورليشن هنا قلت لك والله find the correlation هنا. You need to do the calculation. مثلا هذا واحد من الامثله وهكذا. طيب اي سؤال ثاني شباب؟ Okay. Now, so we had here first order station, second order station. You can think of third order station. Not necessarily. كل ثلاث هذه values يجون في الأكثرين. إذا ما تتغير مع الوقت we call this as third order station. You can have nth order station. That's all. بصفة عامة, if you have nth order stationary, it will give you n minus 1. يعني the second order it's first order. If the third order it's second order. الآن في عندنا concept مهمة اسمها wide sense stationary. wide sense stationary أو stationary in the wide sense ميزة الكونسبت هذه إنها ما تعتمد على PDFs. يعني even I don't know if I don't know the PDFs, I still be able to prove whether it's wide sense stationary by doing some measurements. إيش الوايد sense stationary يقول؟ أنا ما لي علاقة بالPDF. أنا first order or second order ولا شيء. I have no clue كيف الديستريبيوشن حقين هذا بروسيس شكله ولا في أي وقت. I have no clue. لكن أنا I can measure المين الأفريج. أنا إذا عندي سيجمنت تجي أقدر أحسب الأفريج. صح؟ سهل ما يبغى لها if you have a segment can you calculate the average? This is value صح. I can calculate also. I collect information about the relationship between the signal and its shifted version. Easy to calculate, even if I have anything, whether signal or the GBAs or whatever. So, if I have the mean constant, the average ما يتغير الآن إذا بعد 5 دقائق ولا بعد 3 ساعات ما يتغير. Then this is the first condition, and the autocorrelation function was expected value of x of t plus tau, so t and t plus tau. ما له علاقة ولا يعتمد على when did I do the measurement. It only depends on the time difference. If the autocorrelation function does not depend on when did I do the measurement, الآن ولا بعد ساعة ولا بعد نص ساعة ما تفرق. As long as I'm keeping time difference between the samples, the same. If the autocorrelation function only depends on the time difference between the samples, and the mean is constant, we call this as a wide sense stationary. نعطيها wide sense stationary. Okay. ايش ميزة wide sense stationary؟ It's much easier to verify using measure data. Unlike PDF. يعني مثلا خليني اجيب لك الويذر ديستريبيوشن في اماكن كثيره. انك تجيب لي PDF ما سهل انك تجيب PDF. It is not easy to find or to estimate. بينما المين والاوتوكوريشن is much easier to estimate. نفس الشيء GBA، نفس الشيء اي signal seed and so on. Now if I have a second order stationary، نحن عارفين second order means first order means that the mean is constant. And second order means that the autocorrelation function satisfies this property, and it only depends on the time difference. So second order stationary will satisfy these two. So second order stationary gives you wide sense stationary. If it is second order, it's wide sense. However, not necessarily the opposite. The opposite is not necessary. Then in wide sense stationary, did I talk about PDFs? Do I know what PDFs are? I have no clue. أنا ما أعرف حتى كيف جاب distribution شكل. However, I know only the mean is constant and the autocorrelation function depends on time difference. Very simple two criteria. If I know that they are wide sense stationary, I don't have any clue whether what a conclusion about whether it's second order. Okay, sure. هذا nth order ما أتكلم عنها كثير بس يعني nth order in general is kth order station. Nth order station is kth order station with k this time. Now, again, في عندنا concept ثانية which is extremely difficult to verify إلا في الجاوسيان, which is strict sense station. Strict sense means that it's stationary for all objects. We will only be able to verify this when we talk about the Gaussian running process, because wide sense stationary running process, Gaussian running process will be strict sense. However, this is just a very theoretical thing that we don't even know how to do or how to define it. So I have a concept very important. We can't example in a minute. Now, طبعا هي ليش مهمة؟ لأنها much easier to verify using measured data. compared to PDFs. انت زي ما بقول لك الجنرال you might not have access to the PDF. You don't know the PDF. You don't know how to estimate the PDF. فما بالك الجوينت PDF second third fourth order مستحيل. لكن you can measure the mean, you can measure the autocorrelation. Again, just last definition, jointly wide stationary. Jointly means لما نتكلم عن jointly means that we have ايش يا شباب؟ X of t and y of t. So we have two random processes. We have two random processes that are jointly wide stationary. First of all, X of t alone and Y of t alone are individually wide stationary. ايش معناها individually wide stationary يا شباب؟ When we say individually wide stationary means that كل واحدة منهم has a constant mean and the autocorrelation function depends on the time difference. So X of t satisfies these two conditions, Y of t satisfies these. In addition to that, to be jointly stationary, the cross correlation function ما يعتمد على t, يعتمد only on time. So basically it depends only on x, y. Does not depend on t. Okay, does not depend on t. It depends only on time. It doesn't depend when did you do the measurement. اليوم ولا قبل ساعتين ولا. واضح شباب الكونسيبت حق الوايت سيس؟ هذا كويك اكزامبل عشان بس يعني كل المعلومات تدخل مع بعض. I'm giving you a white sense. I'm giving you a random process here. Random process. شكلها كالتالي. X of t equals a cosine omega 0 t plus theta. Okay. Show that this random process is wide sensation. Is it or not? We don't know. Okay. If it is assumed that a and omega 0 are constant. So we have the amplitude is constant, omega 0 is constant. معناها ايش الرandom? Phase is uniformly distributed between 0 and 2 pi. So the phase here has a uniform distribution between 0 and 2 pi. 1 over 2 pi. This is the PDF of the phase. Well, and this is a typical problem in a communication system when you receive a signal with random delay. Random delay translates into random delay. So السؤال is find whether this is a wide stationary or not. How to find that? Check the mean, constant or not. Check the autocorrelation function. Does it depend on t, the reference time, or depends only on the time difference between the signs? So x of t is given like this. The PDF already we know something like that because it's given. So uniformly distributed means that it's given. Now we start with the mean. The mean is what? Is the average of x of t. So we take x of t and put it inside the integral and multiply it by the PDF. صح ولا لا؟ The PDF of theta, d theta. Not dt, d theta. You are averaging over theta. Now we know that if we integrate any cosine for one full period, for you cancel it, you get 0. So first of all, the mean is 0. The second thing is the autocorrelation function. Does it depend on t when the tau only? So the autocorrelation function, expected value of x of t plus tau. So we put x of t here, and we put x of t plus tau. X of t is a cosine omega 0 plus theta. X of t plus tau is a موجودة a ثانية cosine omega 0 t plus tau plus theta. We multiply the two cosines. Cosine is what? Half cosine the difference, the sum plus cosine the difference. Right? So we have expected value of cosine. This the sum of the angle plus cosine the difference between the angle. Now cosine the difference, is it depending on theta? فتنزل تطلع برا الاكسبكتيشن. It's a squared over 2 cosine omega 0. The second one, do you have theta here? So what we are trying, what we are integrating here, we are integrating cosine 13 frequency with theta for one period, which is نفسها بالفكرة. This gives you basically 0. You remove it, right? And you get basically this. تعتمد على التايم ولا مسائل؟ time difference. And because of that it's quite sensitive. المرة الجاية إن شاء الله نكمل. نرجع عليه مرة ثانية عشان يعني نأكد الفكرة.